Excellent. I was hoping for that confirmation. Hi guys, I'm Terry Request, the CEO at UGrocket, and what we do is smartphone RFID. So this is the UHF RFID that Richard was just talking about with Impinj, and we do it with a smartphone interface. So I'm going to go give you a little overview, and then I've got Tony here, who's my CTO, and he'll talk a little technical. So for talking about IoT, Internet of Things, for that to happen, the things need to be digitized. They need to be able to interact. They need to be able to speak up and tell you what's going on, and that's what our focus is. I just want to lay out a little. You guys are looking at different IoT technologies. Let me lay out a little bit where UHF RFID is. In IoT, you can make a split between passive and active technologies. And that's really looking at the tags that go on items. So the active technologies, Bluetooth, iBeacon, Zigbee, Anthem, there are more, but these are representative. And GPS, because the tag is powered, it can communicate with the reader from much farther away, 30 feet up to worldwide. But the downside of that is the tag is powered, making it bulkier, making it more expensive. Usually meaning some type of tag management has to happen at some point. Either needs to be recharged, or the battery needs to be replaced, or the tag just dies and it's no longer available. Passive tags, NFC and UHF, don't have the power in them, which means that they're not going to get that same read distance. The distance between the tag and the reader is going to be a lot shorter, but you're going to get some advantages from that. So let's take a look at what some of those are. So UHF is a passive technology. We're going to get about 2 to 7 meters, 6 to 25 foot read range, depending on the size of the tag and the intricacies in the environment. We like to say sort of a room size read range. There we go. With UHF, you have a rapid multi-tag read capability. That's a lot of letters. Let me try and break that down. What that means is I can read lots of tags essentially at once in a sort of inventory manner. NFC really focused on a single tag at a time. Great for security type applications, payment type applications. UHF, much more for inventory asset management, scanning a room and getting information back from multiple items that are in that room. The tags, as I said, are batteryless. They're passive. They're also much less expensive than active tags. So when you have an implementation where you're looking at lots of items, lots of stuff, or stuff that is inexpensive in itself, then you want to be going with passive tags, with UHF or NFC tags. And one way to think about these is that they're a permanent digital ID. So you're taking a physical object, you're giving it a digital ID. It can now interact in space instead of physically. But since it doesn't need to be recharged or replenished in any way, you can fix it and forget it. It can always carry that ID. Traditionally, UHF has been used in these types of applications, identify objects, especially objects that are very similar or identical. So if you have a lot of the same widget, this can make them unique. So you can identify lots, you can identify individual widgets. Locate a specific item. Where is it without having to go actually see it, because now you have that room size distance that can respond to you. Track items as they move around, where Richard was talking with doorway portals and fixed readers. You can do this with handheld readers also. And take inventory. Look at all the items that are around, count them very quickly. Also traditionally, UHF, not from the tag side, but from the reader and system side, has been pretty expensive and somewhat difficult to use. And our angle on it is to open up UHF, push it down market, make it affordable and accessible and easy to use. That's why the smartphone interface, $500 MSRP for the product. So if you're thinking of building something on UGrocket, you might want to be thinking more about either a small and medium business type product or a way to add on to an enterprise product that can expand in the company or expand into that company's ecosystem. We do work, UHF RFID is a standard. We work with standard UHF, so if you can use UGrocket in conjunction with the Impinj readers, and the data can all be used together. And I'm going to turn it over to Tony.
Hi. So we'll talk a little bit about what applications look like. The stuff in orange is what we provide. The Grocker, which is the reader, connects to Android or iOS devices via the audio cable. So it's just a very quick, easy to use thing. We provide SDKs to write apps on top of. The SDKs are really focused on being very easy to use, and you can use all the kind of extensive RFID functionality, but we're really focused on making it very easy to find tags, which is what RFID is all about. Talking about the tags real quick to kind of what applications tend to look like. The tags generally have a 96-bit ID on them, and that's usually used in one of two ways. It's either used as a unique ID to key it into a database, so you have a bunch of databases about an object, and you use the tag ID for just as an index into that. Or sometimes you use that, and there's also, most tags have user memory, and the most typical amount of that is 64 bytes of user memory. And some types of applications can actually store all their data in just the 96-bit tag ID or the tag ID in user memory, and then you have a standalone application that doesn't need to be connected to a database. Typically, applications will interact with the cloud, and since you're working on an iOS or Android device, it's easy to connect to a backend to have the database of tag items there to understand when you read a tag, what it is that you're reading. We have several different SDKs available. The APIs in all of these are fundamentally the same. They're just in different programming languages. So you can program natively. So on iOS, you're using Objective-C, you're using Java on Android, or you're using C# on Windows. We also have a couple of other development environments that are higher level and multi-platform. Cordova is a web-based system. So basically, you program in JavaScript and HTML, CSS. So then you have a JavaScript interface to our API. Xamarin is Cordova works on iOS and Android. Xamarin also works on iOS or Android. It is a C# based environment, so you can write a C# app and have it work on either iOS or Android. So lots of our developers are doing that. They're using these SDKs, which actually are described on our website here. If you go to dev.ugrocket.com, you can download the SDKs now. There's also a kind of an overview page for each SDK that you read through in 5 minutes, and you'll see, oh yeah, this is basically how I do stuff. You essentially tell the device to start looking for things, and you get a callback as tags are found with the tag ID, and that's the basic way that it's used. There's a couple of other options for development too. One is that we have an application that's available in the iOS App Store and the Google Play Store that's called SendGrok that will basically just scan tags and then send them to your server. So if what you want to have is you want to integrate with a web application, a backend application, you can use SendGrok. You just put in the URL that you want the data to be sent to. There's some other configuration you can do to do things a little different way. But the user basically just hits start and stop. It scans tags. It beeps when it finds them, and then it sends that information up to your server. And that's a way to kind of quickly get data in if you want to just be doing backend development and not want to get around doing development on the iOS or Android device. SendGrok can also be controlled from via URL, so you can have a web application running in the browser on the iOS or Android device that actually calls over to SendGrok and says scan something, and then when the scan's done, it can come back to the web application, and you can integrate like that. That's another kind of easy way to do an application without having to actually write native code.
Great. Tom, I just want to jump in. I don't know how much more you wanted to cover, but in the sense of time, trying to maybe answer some quick questions that people are asking. One is what's the power cycle? Like how long will the unit last on one full charge?
And I was basically right at the end, so the timing is great. The unit, if you're scanning continuously, it'll go an hour and a half to 2 hours on one full charge. But almost all applications are not scanning continuously. They're scanning, they're finding tags, then you're doing something with that information on the phone. So for most applications, it'll last all day. But if you are just scanning continuously, it's an hour and a half to 2 hours. Okay, and I really like the Cordova and the Xamarin. I think that those APIs are going to be pretty popular, given the 24-hour time limit to actually create something. I think a lot of developers might jump on that to have something that they're able to turn around pretty quickly, multi-platform. So that's really nice. I guess the other things that I've seen at hackathons that people tend to ask when it comes to devices like this is latency between the moment that a tag is discovered to the moment that it's seen by their application. Because a lot of times they might want to do something where it's like someone walks into a room and they get a welcome message or what have you, and for that sort of use case, time can matter. Is it in the order of milliseconds or in the order of seconds? It's in the order of milliseconds. If you're trying to do that, you're scanning a tag to where it gets to your app. That time lag is in the order of probably 100 to 300 milliseconds, depending on depending on what exactly is going on. But in user time, it's essentially instantaneous.
Okay, great. And is there a buzzer on the Grocket?
There is a speaker on the Grocket, and you can set it in different modes for how to beep, where it actually will look for a tag and it will beep immediately without even going back to the phone, so that then the sound delay is on the order of a millisecond or less. So it's absolutely instantaneous, because we found that we really needed to do that to be able to get the feedback. If you're basically holding this thing in your hand and it's kind of a very personal device, you want to have that immediate feedback.
Okay, great. All right, sweet. We're going to move on to the next. Running out of time here, so I want to make sure that I don't leave anybody out. So I appreciate Carrie and Tom for your time. This was amazing. I really appreciate you guys putting a presentation together. So I'll pass it on to the next person, which is Punch Through. And I don't see Colin on the call, so I'll take that and basically introduce you to the beans. And I'll mute Carrie. So let's see here. So hopefully you can see my screen. Please write something on if you don't. Let's see. Okay, so the Punch Through beans are basically a really interesting Bluetooth low energy device development board, if you will, that the guys at Punch Through Designs put together. And what's really cool about it is that you can program using your iPhone. So they've ported their entire development environment into an iOS app, which you can download from the App Store. And it just gives you the ability to do all your coding onto this Bluetooth low energy device. Over the air. So it's an Arduino based design. So you would be writing Arduino sketches, which is also really compelling. It operates on a coin cell battery, and we're going to have 20 of these on site. So they have 2 analog I/O pins and 6 digital I/O pins coming out. So you can turn on and off lights. You can read temperature sensors. You can sort of react to the presence or absence of the bean, in a proximity sense. So they're really easy to create as iBeacons if you wanted to sort of do an iBeacon type application where you have a customer facing application that launches your app and does an engagement like a welcome message or what have you when they walk into a space. That's something that you can do with these beans. And the great thing about the work that the guys at Punch have done is they've created a real good community, and their community forum is rich in all sorts of different applications that can sort of host or excuse me, not host, but that they can take form in your particular hack. So if you go onto the community forums, you can then really access kind of this rich knowledge base and answer questions pretty quickly. The great thing also is I'm very familiar with the Bean stack and done several hacks using it. So I'll be on site along with some of the guys on my team, and so we'll be able to again help you out to really get something going rather quickly. So without too much on the beans, it's a great Bluetooth low energy product. I'd say probably one of the more compelling ones that I found. If you have any questions related to the Bluetooth low energy product Bean that we'll be having, feel free to hit us up now or over email. Again, this is going to be webcasted later, so folks can catch up on these things even though they're not here on the call now. So I'll move on to the next presenter.
Okay, great. All right, so yeah, so this is the hardware development kit that we're going to be bringing. It's called our Omni-ID View Starter Kit. Basically, what it is it's 2 of our ProView visual tags that we use primarily in manufacturing, but there are other uses for it as well. A 3-inch and a 4-inch, along with the USB gateway that communicates with those, and as well a ThingMagic RFID reader, which you can use to trigger the view tags and or to also write some information down to them depending on the method that you want to use to communicate with the tags. Along with that, there's documentation and a USB drive with the API that we use. The API requires Windows 7, 32 or 64-bit or higher, and .NET Framework 4.5 or higher to utilize. And basically, yeah, you can use these tags to put down any type of information, whether it be graphical images or whether it's text-based. Both the tags handle both through the API. And yeah, I think we're looking forward to some really interesting uses for our tags.
Great. Thanks for that, Len. Actually, there's one question that I have. Can you hear me, by the way?
I can.
Okay, great. Yeah, one question I have. So this is not, even though you provide the Thing Magic Reader, the actual Omni-ID tag isn't necessarily dependent on that particular reader, right? So theoretically,
That's correct.
yeah. So theoretically, you could create an application that uses whether the Grokr or the Impinj X-ray reader that's ultimately controlling the tag, as an IoT device directly.
That's correct. Yep. You can use any RFID reader that's capable of writing to the passive tag to wake it up and or push data down to it.
Right. And so then the other question that I had is, so there's two tags. What are the pixel width and height for each image?
Ooh, you are.
So sorry, I didn't mean to.
A question I don't know off the top of my head, and it's not in the stage sheet. I do not know that off the top of my head, unfortunately.
Okay, no worries.
Yeah, sorry about that.
So it looks like there's a square sort of size, and then there's more of like a landscape image size, and there's enough pixel densities to obviously show the very small font building intelligent supply chain. So images are possible. They'd likely be written to in some sort of bitmap. So I'm sure that the software helps with that.
Correct. You can send a bitmap image down. There's also a what we call a macro interface that allows you to send just text down, so that you can be just text based. Also barcodes, 2D barcodes are routinely sent to these tags, and you can scan the barcode from the face of the tag as well.
Okay, so there's one question that comes in from the developers. Specifically, Byron's asking, what's different about these tags than normal tags, and I'll let you answer that.
Okay, so normal passive RFID. This tag is different because it's dual, right? It has a passive RFID channel that you can use to wake the tag up and communicate with the tag. It also has the 433 megahertz channel, which is, if you're looking at the screen right now, there's a little silver box right below the tags. That's our USB gateway that you can use to communicate to the tags via the 433 megahertz.
Got it. And I think that maybe even from even a higher level, Byron, these are tags that have a display. So what that means is that you can deploy these on an asset, and you can change what that particular display is showing. So it can present a barcode, for instance. And so you can use an RFID reader to ultimately engage this display, which is an e-ink display. So it's incredibly low power, and it ultimately will stay in that form forever. Basically you're only burning power when you change the image. So that's why it's really interesting to use in different asset tracking applications, because you can change the barcode, which can ultimately allow for the asset to have a different behavior in your supply chain. Or if you're applying it to something completely different, whether you want to moderate people entering a space in an event, and you want to show something on a little screen that may be their welcome card at a banquet table, for instance, that's something that you could potentially do with this device. All right, so Len, thank you so much, and sorry for the mix up there, and we're sort of running out of time, but I'm hoping my other vendors don't leave me. So we're going to move on.
Well, thank you.
All right, Len, thanks.